Hey, what's going on, Internet? Lou here, and I am back with another tutorial. But before we get to that, I want to get one thing out of the way. I am aware that there is a hole in my t-shirt. This is my all-time favorite t-shirt. I'm not ready to let it go yet. So before one of you wise guys says, "Hey, look, there's a hole in his t-shirt," I beat you to it. Anyway, today I'm going to be showing you guys how to configure, compile, and install the Zen kernel in Fedora 16. Now, I've been really encouraged lately because I've received a lot of messages on YouTube and even a few tweets on Twitter from you guys basically saying that, hey, you know, I've seen your videos, I see that you use Fedora, other distros that I've been using haven't worked out great for me lately. I've tried Fedora and it's been awesome. I'm really great. It's been really great to hear that because, you know, if I can help anybody, you know, that's what I'm here for. That's why I make these videos. So it makes me feel good when I see that people have been impacted in a positive way from the videos that I have here. I want to take a brief second while we brought up my videos, and if you guys can do me a favor, if you find my videos helpful, if you find them informative, if you like them, give them a thumbs up, give them a like. Favorite the video, share the video on Google+, share it on Twitter. I'm really trying to get my videos out to the masses and educate more people on Linux or help Linux users get more comfortable on the Linux desktop. So if you could do that for me, that would be awesome. So you may be asking yourself, what is the Zen kernel? So I'm going to head over to the Zen kernel's website so we can read a little bit about that. And as per usual, if you look in the video description below, you'll find a blog post that has all of the terminal commands that we're going to be using today. It has the Zen kernel's website, a link to that, and some more information I think you'll find helpful. So make sure to follow that blog post. And again, give it a +1, share it on Twitter, and do all that good stuff. All right, so with that out of the way, let's go over to zen-kernel.org and take a look a little bit here at what exactly the Zen kernel is. Now, for those of you who don't know or maybe unfamiliar at what a kernel is, every major OS has a kernel. Windows has a kernel, Mac OS X has a kernel, BSD has a kernel, Linux has a kernel. Every operating system basically has a kernel. And to make a really complicated topic like the kernel into something very simple, I guess I would summarize it in that the kernel is what allows your hardware to speak to your software. Okay, it's basically the brains of your operating system. That is really reducing the kernel down to something very simple, but that's essentially what the kernel is. So the Zen kernel is the result of a collaborative effort of kernel hackers to provide the best Linux kernel possible for everyday systems. We include code that's not included in the mainline kernel in an attempt to create an all-around better kernel for desktops. This is done by including new features, supporting latest hardware, and including various code and optimizations to better suit desktops. Zen is a 100% community-oriented project, and so, as a result, everybody can contribute to the project. Zen is almost always more up-to-date than your distributor's default kernel. Zen is split up into two trees. There's the Zen stable and unstable. The stable tree follows Linux releases, while the unstable tree follows the Linux Git tree. So that's a little bit about what the Zen kernel is. Now, just a word of caution. You can really get yourself into trouble by installing a kernel from an unfamiliar source. There's a lot of security vulnerabilities that you could be exposing yourself to. Just all around bad stuff. So please, don't just install a kernel from anybody that you find out on the internet. Make sure it's a well-known source. Now, the Zen kernel project's been around for a while. They mainly produce kernels for Debian. However, you can obviously compile and install them on Ubuntu. I believe the Arch AUR repository also has some precompiled kernels in that repo for people to install, specifically Zen kernels or Liquorix kernels. So, you know, it's a trusted project. It's been around for a while. They have a public Git, so you can view any of their source code. In fact, we're going to be downloading their source code today. So, you know, make sure that it's a trusted source. I mentioned that blog post that I'm going to be including in the video description below, and here it is. Now, first thing that you're going to want to do is what you're going to want to do is install these packages here. If you don't already have them installed on your system, install these packages. You're going to need these to do everything that we're doing today. And under here, let's see, how to clone the Zen stable Git repository. All you're going to do is you're going to copy this line, and you're going to paste it into a terminal, and you're going to hit enter. A little message is going to pop up saying cloning into Zen stable Git, and it's going to start pulling down all the source. Now, a benefit in the method that I'm going to show you today on how to compile and configure and install this in Fedora is now that we clone this Zen stable Git, we'll have the source on our machine. We only have to download the source one time. I'll show you a little bit more toward, maybe in another video, how to use Git. But what you can basically do is you can query out to the Zen stable Git repository, have it compare your source with the source that's up on Git, and then what it'll do is it'll automatically pull down any additions, deletions, or subtractions. It'll patch everything. It'll configure your source for you, so you don't have to do it, which is really cool. Also, the Zen kernel source includes things like BFS and BFQ, commonly used patches to the vanilla kernel. So you don't have to go out and pull down all those patches and then patch the kernel. It's already done for you, which is really awesome. Okay, so this is going to take you, depending on your internet connection, it's about 150 megabytes, and it is at a governed speed, download speed. I don't think they have a whole lot of servers for this, so it may take you 15 minutes or so to pull down all that source. So there you go. Go ahead and clone the Zen stable Git by just copy and pasting that terminal command right in there. Next thing we want to do is we want to create a directory where we're going to compile this kernel. Now, I am not going to show you how to put it into an RPM package. There's a couple of reasons for this. I absolutely abhor compiling into an RPM. I think there's just way too many steps. That's one thing I do miss about Debian. Compiling into a deb package is so much easier than compiling it into an RPM package. And honestly, all the reasons why you may want to put it into an RPM package, all the benefits I'm really not going to take advantage of. Redistribution, I'm not compiling kernels for the masses. I'm doing it specifically for my system and my hardware. So really, the person that's going to benefit most from my kernel is me. So, it's really not going to matter as far as redistribution. An RPM package you can redistribute. I'm not going to do that. The second being, if you use yum to install that RPM, you also can use yum to delete the kernel. Again, it only takes going into a few different directories and deleting a few files to get that kernel off your system if you wanted to remove it. So honestly, that doesn't really matter. Compilation time. I find that it takes a lot more time to build into an RPM than it does to compile the way I'm showing you today. Now, if you're on a modern computer and have at least a dual-core processor, this process could take you anywhere from 15 minutes all the way up to maybe 50 minutes. I'm going to show you how to optimize this kernel compilation process today if you have a multi-core machine. But again, it could take a while, so if you can save a little bit of time, that's really great. So what we're going to do again is we want to create a place where we're going to compile this kernel. I always compile out of my home directory. Some kernel guides online are going to tell you to build out of your user source directory. Bad idea. Again, it's just as far as security is concerned, you don't want to be doing that. And out of your user source directory, it's just not a good idea. Compile it out of your home directory. That's probably the best place to do it. To keep things neat, I like to create a directory called Kernel. I know, I was real creative when I came up with that. And then put everything inside that directory. So that's what we're going to do first. We're going to execute this by typing mkdir. In Linux, that's the command to create a new directory. We're going to call it kernel. Alright, so we just created our kernel directory. Now what we want to do is I'm going to move all of the Zen kernel source inside of this particular directory. We do that by typing mv, that's the move command in Linux. What do we want to move? Well, we want to move Zen stable. And where do we want to put it? Inside kernel. There we go. Alright, now we need to start our kernel configuration with what we refer to as a config. Now, if you're a kernel guru, you can probably start from scratch and go through all of the options, and you know exactly what to include and not include. You know exactly what to compile as a module, so on and so forth. If you're new, what you want to do is you want to start off with a good starting point. Now that your configuration tells the kernel what to include or exclude within your kernel. If you want to have things built directly into the kernel, or you want to have them loaded as modules as needed, it tells it it's a good starting point. It's a foundation. Now, a good rule of thumb is just to start with the current configuration that your particular distribution of Linux has already. And I'm going to show you where to find that and how to use it. So you're going to find that in your boot directory. All right. So what we want to do is we want to cd into boot. Now type ls. ls is going to list everything within that directory. Now what we're going to do is we're going to use the most recent config. Okay, so we're going to type cp for copy, and we're going to use the 3.1.4 config. That just so happens to be what the Zen stable source is based on, is 3.1.4, and we want to put it in the new kernel directory that I just created. There we go. So if we now cd into kernel and type ls, you are going to see that there's the config that I just copied and the Zen stable kernel source. Next thing that I want to do is I want to symbolically link the Zen stable kernel source with a directory we're going to create called Linux. Okay? The reason we're going to do this is during the building process of certain modules within the kernel, it's going to look for this directory called Linux. When I started learning how to put kernels together, this is just how I was taught. It's a good practice that I've always had, and I'm going to show you guys how to do that. To symbolically link, what we're going to do is we're going to type ln-s Zen stable, and then we're going to type space Linux. Now if you hit ls again, you're going to see that we have our config that we copied out of our boot directory, the new Linux directory, and Zen stable. It's exactly what we want. The next thing we want to do is we want to prepare our source for configuration and compilation. The way that we're going to do that is we're going to cd into Linux. Now we're going to run the commands make clean and make Mr. Proper. This is going to clean everything, and it's going to get everything exactly the way that it needs to be for us to move forward in the compilation and the configuration process. Now, you see here it's outputting a lot of different stuff here, proceeding with the word clean. It's doing this because I've actually built a kernel out of this source already. Now, if you're using a completely fresh set of sources, when you hit enter after you type make clean and make Mr. Proper, it's probably not going to output anything. So don't be alarmed if you don't see a lot of output like I have here. That's because I've already built a kernel out of this source. Alright? So that's all done. What we want to do now is we want to cd and space ... That's going to bring us out one directory back. So now we're still within my kernel directory. And we want to copy the config file into our Zen stable source, but we want to rename it .config. So that's how you do that. Now type enter. If we cd, we'll cd into Linux and type ls space -a. It's going to list everything within that directory, including any hidden files or folders. You're going to notice that the config that I copied and renamed to .config is in there. Next phase in the process is we want to really customize our configuration. And one of the things that we're going to want to do is we're going to want to compare our current configuration with the new one that we have in our Zen source code, and we want to see if there, what new features there are, and we want to be able to choose what features we want to use or not use. The way that we're going to do that is we're going to execute the command make old config. By doing this, it's going to run a script, okay, and it's going to bring us now into a configuration process. What we're going to do here is we're going to start off and go section by section. Starts in general setup, and we're going to go through. Now, what's new is they have a new CPU scheduler, the BFS scheduler. That's my personal favorite. I'm not going to get into what it is or why it's my favorite, but It's the one I like to use. We're going to go with number 1. We're going to hit enter. Now, as you're going through this process, if you don't know what a feature is, if you just hit enter, it's going to choose whatever the default selection is. That's what I suggest to do. All right, let's see here. All right, yeah, I chose one. Okay. Automatically use schedule ISO policy for X. We're going to go with the default selection here. Zentune profile. It defaults to custom, but I'm going to go with option number 1. BFQ IO scheduler. Do I want to include it? Yes, I do. That's my favorite one. BFQ hierarchical scheduling support. Yes, I want to include that. Default IO scheduler. Number 3. We're going to go with BFQ. We're going to go with the default selection on this. Timer frequency. I know you guys probably want to go straight down to 10,000 hertz, but don't do that. 1,000 hertz, which happens to be the default here, is plenty high enough. You go any higher, what will probably end up happening is you'll end up breaking a module. So don't go any higher than 1,000 hertz. That's as high as you want it to be, really. So we're going to go with option number 4. ThinkPad support. I don't have a ThinkPad, so we're going to go with a no on this one. RAID. We're going to go hit enter, go with the default. Colored kernel message output. No, thank you. We're going to go with default on this one. Select random available logo. No. We're going to go with no tux logo. Arch, no. Gentoo, no. Slackware, no. Debian, no. Fedora. I will pick the glossy for Fedora. We won't go with that logo. BSD Devil, no. FreeBSD. Okay. USB HID mouse interrupt pulling. We'll go with the default. Default. ThinkPad again. No thanks. Okay. There it is. There's our make old config. Now, if we want to take our config to an even further level, I can show you how to kind of use a graphical way to do this. We're going to type make menu config. We're going to hit enter. Okay, what we want to do now is we want to load the config that we just saved from our make old config. We're going to go all the way to the bottom, right here where it says load an alternate configuration file. Hit enter, and then just hit OK. So there we go. Let's start out at the top. General setup. There we go. Our CPU scheduler is set up to be the BFS. That's what we want. Zentune profile default. That's what we selected previously. That's what we want. Optimize for size, yes. Now, a smaller kernel is a faster kernel. Your goal with putting a kernel together is to really optimize everything for your hardware. Take out anything that you don't need, okay, and specifically tune the kernel for what you have. So we want to optimize this for size. Now, if you don't know what something is, you can come over down here to where it says help, okay, and then hit enter. And it'll give you a brief description. Not everything has a description, but you know, if you're unsure, go with the help. If you're unsure of what something is, just let it be at whatever the default is. Don't mess with it, okay? Because if you don't include something that you really need, you may really mess your system up. All right, so. Alright, this section we're good. I'm not going to mess with anything else. Let's go to Enable Block Layer. IO Schedulers. There it is. There's a BFQ hierarchical scheduling support that we selected previously, and our default IO scheduler is BFQ. That's what we want. So we're going to exit and exit. Here's where we're going to start to tailor things a little bit. Processor type and features. Now, when you want to include something in the terminal, in the kernel, you see here there's an asterisk. That means that's going to be built into the kernel. You basically get that asterisk by selecting Y on your keyboard. If you want to remove something, you simply select N on your keyboard for no. Okay? Or if you want to build something as a module, you select M. Okay? Now let's come down here to processor family. Every Linux distribution is going to use this by default, just because it obviously you know, the distribution maker does not know what type of system you have, so it's going to go with a generic 64-bit. If you have a 64-bit system, it'll have a generic 64-bit processor selection here. However, I am on a newer Intel processor, so I'm going to go with this Core 2 newer Xeon option. I don't have an IBM. I don't need IBM, so we're going to hit N there. Hyper-threading. You're going to want that. My processor does support hyper-threading. Preemption model is voluntary kernel. Well, we want to change that. We want a low latency desktop. Okay, so your interactivity is very quick. So we're going to choose low latency desktop preemptible kernel. Alright, I do not have an AMD chip. Do not need that. I don't have a Dell laptop. I don't need that. Again, AMD, don't need it. There's a lot of options here. I'm not going to go through all of them. Alright, there's our timer frequency. It's set at 1000 Hertz, just what we want. Alright, let's exit out of here. Go down into power management. There we go. Suspend to RAM. If you're on a laptop, you're going to want that. Hibernate, you're also going to want that. Let's see here. Let's come down to memory power savings. Instead of having this built as a module, I'm going to include that in the kernel by selecting yes. Let's go up to CPU frequency scaling. Alright. Without having to go through all these governors, basically, the default here is on demand. So that means it's going to, if you're on a laptop, you'll notice this especially as far as battery is concerned. On demand scales your processor frequency from very low to the highest it can go. It really doesn't do anything in between. It's either really low or really high. So, you know, when your system's just maybe sitting there idling or not doing anything that's very CPU intensive, and maybe it'll toggle down to that really low frequency setting. Put a lot of strain on the system. It may shoot up to as high as it can go. Okay. If you're on a laptop, if you're a college student, if you're going from, you're spending the day at school and you need your laptop battery to last all day, you may want to think about going with something like Power Save or Conservative. Again, go to the help section if you want a little bit more of an explanation on what each one of those is. I don't really travel a lot with my laptop. I use it more like a desktop attached to an external monitor. I'm going to go with the performance kernel. This basically keeps your processor pinged out at the highest frequency it has. Your and you know, essentially, it's going to make everything extremely fast. So we're going to leave that set there to performance. Come down here to the CPU frequency scaling drivers. Again, I'm not on. I don't have an AMD machine, so I'm going to not include that. All right. Let's come down to kernel hacking. Kernel debugging. I'm going to select no. We're not going to include that. If you go to help, you just see that it says say yes here if you're developing drivers or trying to debug and identify kernel problems. I'm doing neither of those. I'm pretty sure you're probably not either, so let's go with a no on that one. That's pretty much it. Okay, so that's basically a decent configuration for my system already. I'm going to go to exit. It's going to ask me, do I want to save my configuration? I'm going to say yes. Now, at this point, the only thing we have left to do is, if you'd like to give your kernel a custom name, for instance, if we go here to our system monitor, and you see here where it says kernel Linux 3.1.4, and then, you know, it has this here at the end. If you're going to be upgrading or changing your kernel on a regular basis, to differentiate one kernel from another, you could give it a custom name so it would show up here. The way that you do that is if you go into your Zen source directory, you're going to notice something down here called the make file. If you open that up in a text editor, I just double click it, it opens up gedit for me. Your fourth option down, you're going to see extra version equals. It's going to say Zen. Here's where you can type in whatever name you want for your kernel. Any custom name at all. Keep in mind you can't use capital letters, you can't use special characters, you can't leave spaces between words. Excuse me, you got to keep dashes in between the things that you do. And I believe there's a 64-character limit. So keep all those things in mind. But if you want to put a short little name in there so you can differentiate one kernel from another, by all means, go ahead and do so. After you're done, just click Save, and that's that. Now, we've configured it. All we've got to do now is compile it. We compile by typing the command make. Now, here's where you can optimize the compilation process. I'm going to use the J flag. I'm going to say -J5. Reason being is, this is going to take advantage of my quad-core system, okay? Now, the reason why it's J5 is because the rule of thumb is you add 1 to however many cores you have. I have 4 cores. It's going to be -J5. If you're on an older Core 2 Duo machine, it would be -J3. If you're on a machine that is not dual core, this doesn't benefit you at all. All you would do is run make and hit enter. Okay, so at this point now, we're ready to build the kernel. So we type make space -J5, and I'm going to hit enter. You're going to see, if I were to hit enter, it's going to start the whole build process, okay? Again, depending on your hardware, this could take anywhere from, say, 15 minutes to 50 minutes, or maybe even more if you're in a really old machine. Okay, so be patient. This is going to be a 2-part video series, okay? So I'm going to let this kernel build, and when it's done building, I'm going to come back, I'm going to show you how to install the kernel, as well as configure your grub bootloader to boot from that kernel by default. Okay? Alright, so we will see you guys back in part 2.